Okay. So we did the fire in the short grass prairie. So if you want to go to the next slide, Raymond. So the slide before was just showing a map. Draven, I don't know if you can go back up to that. But basically, short grass prairie on this map is shown in yellow. You can see that it ranges from Canada all the way south far into Texas. And I think this is more of a historical range, and it's probably a lot more of remnants today since there's a lot more fragmentation from development, energy, roads, and all of that fun stuff. So it's not quite as extensive, but that gives a general idea of the area that we covered. Next slide, Draven. Just a quick intro. So basically, short grass prairie has been dominated throughout the past with buffalo grass and blue grama. Blue grama is pictured at the bottom left of the slide and buffalo grass at the bottom right. Some of the other grasses included citrus grama, little blue stem, and western wheatgrass. Just a couple of other facts here is the annual precipitation ranges between 15 and 20 inches. I'm sure this varies more on more of a smaller scale, but that's just in general. And then it's estimated that less than 23% of the true short grass prairie still exists in native vegetation today. Next slide. Historical fire regime of the shortgrass prairie. So it's a little challenging to find fire scars in the prairie because there's not many trees to pull data from, but it is estimated that within that area it occurred every 5 to 10 years, and then in areas where there weren't natural fuel breaks such as streams or other things, that every 15 to 30 years fire would occur, and it could be large extent again without those natural fire breaks. Usually the severity of the fire was mixed and sometimes high severity that would consume all of the biomass. And some of the ways they kind of have figured out these fire regimes is by taking charcoal fragments from lake sediment shores. And they also discovered that obviously post-settlement, there was a decrease in the number of fires due to fire suppression. There's also historical accounts that concluded fire size and frequency decreased since the 1880s, which is also coincides with the time period settlement. And let's see what else here. And then obviously the historical regimes are no longer functioning due to croplands coming in, agriculture, human settlement, and all the things that come with that. And another important note is in this area, there was a lot of grazing herbivores, back in the day, like bison. Now we have, cattle and things like that. And in the past, the livestock would contribute to keeping that fuel at a low level, and then the cattle declining that frequency of fire because of the reduction of fuel. Next slide. So that kind of ties into the fire's role in shaping the shortgrass prairie. So again, fire and livestock really played a part, and not just livestock, but herbivores before settlement played a part in shaping the shortgrass prairie. Natural wildfires have been a component of grasslands for over 300 million years, and played a big role in creating and maintaining grassland ecosystems, helping create a mosaic of denser and less dense grasses where mammals and birds evolved with the habitat. Fire was a big role in preventing encroachment of woody plants and invasive species, and then also stimulated production through nutrient cycling. And then again, burn areas attracted those large grazers from the fresh new growth, and that helped shift the mosaic. And Native Americans were also using fire before we settled an area, and that influenced the vegetation. But typically didn't destroy the grass cover, and those fires were usually set during the spring and the fall. Next slide.
Okay, so for this one, as just covered, fire's been used for a long time for a lot of different things. It can modify the habitat and also help with hunting, which I cover more later. It can be a double-edged sword because especially if you're using it for something like hunting, it could help in the short term, but be damaging long term. So you really need to consider all the short and long-term angles on that, on if it's going to be the right choice for you. Most of the studies that I found on how fire's been used in shortgrass prairies came from the Forest Service. So this is mostly their experiments. But especially in shortgrass prairies, it restricts woody plants so they don't take over the grassland environment. They can remove leaf litter, allow sunlight through. And a lot of these ecosystems are somewhat dependent on fire to continue their natural cycles. So if you suppress that fire, then those woody plants and leaf litter really build up. And if a fire sneaks through your suppression, it'll be a quote unquote worse fire than if you had just let things burn periodically. And then on the next slide, it can help increase species diversity. And then with hunting, since it recycles nutrients back into the soil, it should increase foliage and cover. And then it'll attract more deer and other animals to the area. It's often not used alone, I will say. It would be in conjunction with grazing methods or whatever else you're doing. And then lastly, it can also help deter pests and disease.
All right, now we're moving on to the biotic and abiotic effects of fire in the shortgrass prairie. Here's just some photos kind of showing like there's some prescribed burn here, some biological soil crust, some erosion, and some grazing bison. Come on. So biological soil crust, for anyone who doesn't know, it's basically a community of microorganisms that live in the soil in semi-arid and arid environments. They play a crucial role in steppe ecosystems, and they can heavily contribute to nutrient cycling, soil fertility, soil stability, and seed germination. when we're looking at the effects of fire in this ecosystem, one of the problems is that it can easily damage the soil crust, and the soil crust can take anywhere from a few years to more than 1,000 years to recover. Recovery time is kind of dependent on the severity of disturbance, soil type, and climate. And there is some research that suggests that the seasonality of burning may actually influence the extent of damage that these soil. Moving on to vegetation. So a lot of like early research focused on blue gamma and buffalo grass. The scope of the research was pretty narrow. The idea was kind of the research really focused on how quickly they can regenerate grass for grazing livestock. So with that narrow scope, a lot of weak inferences were made, and it was initially thought to have a negative impact on the perennial grass species. Later on, though, more research has been done, and some of that past research has been kind of reanalyzed, and it would seem that fire has a predominantly positive or neutral impact on these species. Vegetation response can be variable. It's usually influenced by seasonality of fire, as well as climatic factors, precipitation. For example, early spring burns have been shown to produce a positive or neutral response, and late spring burns have been shown to produce a negative response in the recovery of like blue gamma and buffalo grass. Fall burns produce more herbage than spring burns. And there's been research that suggests that, again, perennial species may be more resistant to defoliation during periods of dormancy. So really, when looking at vegetation response, yeah, it's seasonality is a pretty big factor. As mentioned before, one of the rules of fire is it decreases woody cover and encroachment. And then some responses are, an initial decrease in herbaceous cover and forbs, and then potential or positive impacts to biodiversity and density. So yeah, generally following fire, there might be a short decline, but then it's usually followed by more species and higher amounts of those species repopulating. Wildlife, the responses of birds, mammals, and insects are diverse and variable and driven by both indirect and direct effects of fire. Obviously, the direct effects of fire are mortality. That mostly just impacts species of rodents and some insects, pretty much anything that can't get out of the way. But when we're talking about indirect effects, we're mostly looking at habitat change and how that influences population dynamics. Again, strongly influenced by seasonality of burn and climate. Some examples of studies that have found that studies that have focused on like wildlife response, like rodent populations have been found to immediately decline following a fire for 6 months and then quickly rebound with the appearance of new seed sources and insects. Some populations of insects increase pretty rapidly after fire, like white grubs and xylem-sucking cicada nymphs. One study found that the population of short-horned grasshoppers would be decreased following burning, and that if applied during the right time, prescription burning can actually be an effective management goal for these. And then, yeah, carnivores, omnivores, and ungulates increase in population in response to increased food and forage. And bird populations, they can be kind of vulnerable to fire because the ground nesting species generally rely on thick grass and cover to nest in. But other than that, raptors and birds of prey generally increase as well following the increase in rodents. And then moving on to abiotic effects, really what we're looking at is two impacts would be soil heating and impacts water quality. Because grasslands generally experience fast-moving and wind-driven fires, the flame resonance time of fire is much lower than in like a timber or wildland fire. So typically we don't see a significant soil heating. Fire can alter the properties of physical properties of soil. It can cause hydrophobic soils and it can lead to erosion. However, in a grassland environment, it usually has to be pretty severe. The loss of organic matter can reduce soil water infiltration. Again, that's usually only observed in high severity fires. And then watershed impacts, high severity fires can mobilize nutrients and sediments, which can potentially impact water quality. There's alignment of factors such as drought, high temps, and low relative humidity can result in large extent fires, which then result in large scale erosion events. These can disrupt hydrological function and potentially lead to desertification. A large fire that burned in Texas actually in 2011, over like 55,000 hectares burned, and they started to see massive desertification in some of these areas. Other than that, increased stream flow is a potential side effect. Prescription burn in Texas saw that stream flows increased by more than 1,000%. So, and that kind of wraps it up for shortgrass prairie. So, thanks.